Let's go ahead and see how we can use this formula. So this is the formula we often use to determine future value of an annuity. So let me go ahead and define these components for you. Here, F is going to represent the future value of an annuity. So let's call it future value. And this R, big R, it's going to be representing the periodic payment. And little r, it's the same r from compound interest, so it's the interest rate. And n is going to represent the number of times the interest is compounded, so number of times an interest is compounded. And the last component we have is t, so t is going to represent time in years. So that would be the unit for time. So once we know these components, we can figure out a future amount of a savings. Or let's go ahead and take a look at our first example. So this will be the problem I want to work on. So here's our problem, and we want to figure out the future amount. So let's suppose Taylor is paid on the first day of the month, and $80 is automatically deducted from her pay, deposited into a saving account. So you can think of the $80 is the constant deposit, so we'll call that R value. That's 80. And in the saving accounts, it pays 2.5% interest. So this is going to be your interest rate. So let's call that little r, that is 2.5%. And when you plug this in the formula, you want to convert it to decimal, which is 0.025. And the interest is compounded monthly, so n is the number of times an interest is compounded. In this case, n will be monthly, so that's 12 months in a year. And we want to know how much will be in the account after 3 years and 9 months. So that will be time. So t is going to be 3 years and 9 months. So you want to convert that into years. 9 months is equivalent to 9 over 12 years. So we can say this is 3.75 years. That'll be the value for t, because 9 over 12 will give you a 0.75. So we have everything given, and we're looking for how much money will she have after this many period of time. So we can just simply use this formula above. So the future amount, F, is going to be equal to R, which is 80 in this case, times 1 plus the little r, that's 0.025 over 12, that's n, to the power 12 times year, that's 3.75. Minus 1 all over r over n, that's 0.025 over 12. So I just set it up how the formula is given. So now we just simply plug this in our calculator. So this is going to be 80 times, so 0.025 over 12, that's about 0.002. So you'll have 1 plus that, so that's 1.002 to the power 12 times 3.75, that's about 45. And we subtract 1 from it, all over 0.002. So that's 0.025 over 12. And then if you put this in your calculator carefully, you'll get about $3,777.44. So that's how much money Taylor would have in the account after 3 years and 9 months. Here's our next example. So we'll be using the same formula. We have the future amount is equal to R, which is the periodic payment, times 1 plus R over n to the power n times t minus 1 all over R over n. So that's the formula we know, and we went over the components previously. So we want to know the periodic payment, which will amount to a sum of 15,000 if an interest rate of this much is compounded annually, at the end of 16 consecutive years. All right, so we're looking for periodic payments. So periodic payments meaning big R. That's the question mark. So we know the future value. So we know the total sum happens to be 15,000. So this is 15,000 at an interest rate of 6%. So that's 0.06. It is compounded annually. So n is the number of time you're compounding. That's 1 for 16 consecutive years. So that means for 16 years. So let's go ahead and set this up. So we have f is given, that is 15,000 is equal to r, we don't know, that's what we're looking for, times 1 plus r over n. So that's simply 0.06 over 1. We don't need to write that. To the power n times t, that will be 16 times t. Minus 1 all over r over n, that's 0.06 over 1. Now you just cross multiply and manipulate this algebraic formula to isolate this variable right here. That's the variable we want to solve. So let's go ahead and get rid of this first. Since it's division, we're going to multiply by 0.06. So 15,000 times 0.06 is equal to r times all of this. That's 1.06 to the power 16 minus 1. And now you get a number, so 15,000 times 0.06, that's about 900, is equal to r times all of this, 1.06 to the power 16 minus 1. Now if you want, you can of course find this number and then divide by that number. So let's go ahead and do that. So I can go ahead and plug that in my calculator. So 1.06 to the 16th power, subtract 1, that's about 1.54. And you have 900 to the left. Now let's go ahead and divide by that number, since that's the last thing we need to do to isolate r. So this is divided by 1.54 on both sides, and that will give you r is equal to 900 over 1.54. And that's about $584.28. So that's the amount she would have to pay, or this individual would have to make periodic payment of this much to make it up to 15,000 at this given year. Right, so a little bit manipulation with this formula. I hope this makes sense.